yeah, in this video we are going to look at how we can combine some of our power rules that we've gone over to come up with yet one more multiplication rule of exponents. Let's check this problem out right here before we get into the exercises. We're going to come up with a rule. What we've got going on now is that we've got a product raised to a power. Ooh, what do we do? Well, let's expand it out, just like we've been doing here. So you've got a product of numbers, a cubed times b squared is the product, all raised to the fourth. Now you might even have an inkling, an intuition, or a little thought of what you want to do. Let's see if your inkling is right. So raising something to the fourth means if we expand this out, we repeatedly multiply this whole thing to the fourth power. So it will be a cubed b squared times itself 4 times. So I'm going to write that out 4 times. As awful as that is, a cubed b squared times, that's once. Count with me, twice. 3 times a cubed b squared, and then 4 times. My word, that is a lot of multiplications. The point being is that everything inside of the parentheses gets multiplied by itself 4 times. So what you've got going on here is, if we use the commutative property and regroup everything based on the same basis, we're going to get a cubed times itself 4 times. So you have this going on. And then you're going to get b squared multiplied by itself 4 times. And again, I'm going over why this works, this rule that we're about to come up with, not how you're to do every problem. This would be insane if you had to do this every time. So what you really have here is you've got a to the third multiplied by itself 4 times, or a to the 3 times 4 times b to the 2 times 4. And we know that we'd be adding 3 4 times, which is why I'm multiplying there. So we end up with a to the 12th times b to the 8th. So what we essentially did is we used this old rule. We basically looked at this problem and said, this is the same thing as a cubed to the 4th times b squared to the 4th. And we used the rule that we learned in a previous video. We multiply the powers. So you're essentially distributing this exponent and multiplying it to every exponent in the problem. That's it. Very cool. So let me show you the general rule. When you have a product raised to a power, you take that exponent and we multiply it by all of the exponents within the product. So this becomes a to the mc times b to the nc. That's it. That's all there is to it. Now let's practice some problems. Now that we've got the y down and we see the pattern here, let's make this really, really simple. So here we've got a product raised to a power. We're not going to expand it out like that. We're going to use our rule. You've got 3 times 6 and 3 times 7. So that's going to be m to the 6 times 3 times r to the 7 times 3. Keep in mind, this step is what I usually do mentally, but it's a good idea to show out your work to get that partial credit on a test or to just follow your work. 6 times 3 is 18, so we have m to the 18th times r to the 21st, which makes sense. You'll have 3 groups of m to the 6th and 3 groups of r to the 7th, giving you that final answer. Number 2, oh no, we've got a number inside. What do we do? Easy now, we got this. We are squaring everything inside of here. So just keep in mind that this -6 I'm going to do off to the side is really -6 raised to the first. That's really what's going on there. So you're going to square that, right? You're taking that and you're squaring it. And I know that looks really weird with all the parentheses, but just imagine raising all of that to the second. So -6 squared is 36. Then x doesn't have an exponent, which means we know it's raised to the first. 2 times 1 is 2. So that's x squared. And then 2 times 3, 3 being the exponent of the y, is y to the 6th. And that is your final answer. The key here is don't just distribute the 2 to here and say, oh, it's -6 squared. That'll get you a negative answer. The negative is also being raised to the second power, giving you a positive number. Last but certainly not least, we got a juggernaut of a problem. I've got 5x to the 7th times that whole product being raised to the 4th. We'll do the order of operations. It rules all operations. And we'll deal with this exponent to this group first before multiplying by 5x to the 7th, right? Exponents first before products, before multiplication. So I'll deal with this. We're going to distribute this. That's a 1. It's a power of 1 to each of those powers. So we keep the 5x to the 7th times 2 to the 1 times 4. So that'll be 2 to the 4th times x to the 3 times 4 is x to the 12th times y to the 4 times 4, which is y to the 16th. Now we're ready to simplify some things. First things first, I'm going to kind of do a little do-si-do, the commutative property. That's 5 times 2 to the 4th. I'm going to simplify to 16. That's 2 times 2 times 2 times 2. This is x to the 7th times x to the 12th. So in my head, I'm doing this next step, times y to the 16th. So I might not show that workout, but here we're going to do it. 5 times 16 is 80. X to the 7th times x to the 12th. We have the same bases, so we add the exponents, which is x to the 19th, or x to the 7 plus 12, and then y to the 16th stands alone. These exponent problems, no matter how involved or basic they are, it's very important that you take it one basic step at a time. Understand your rules and why they work, and then practice them individually. Then you can start putting them together, and putting a big idea together with lots of rules is as simple as focusing on one rule, one step at a time, and not doing everything all at once. The analogy I use often is when you're faced with a big project like cleaning up your room, right? It's a pigsty, it's a mess. Instead of just taking everything all at once in one big clump, throwing it up in the air and hoping that everything lands in the right spot, focus on one part. It might be that pile of laundry over there that's starting to stink and turn yellow, right? It's probably not healthy. Deal with that first. Once you have that picked up, go to another spot in the room, that ham sandwich or piece of broccoli that's sitting on your wall, which is strange. Scrape that off and then continue to deal with the mess one piece at a time. Before you know it, your room is nice and clean. Sweet. Go rock some of these problems.